So as part of the today's class, we are going to see why Hadoop and what is Hadoop and how it will work. What are the main components of the Hadoop? So as part of the today's class, we are going to see that. So to understand why Hadoop, we have to understand what is the a general process or traditional approach how we are processing the data. So these are the agenda, these are the things we are going to see. In a traditional approach of storing and processing the data, traditional approach means the existing system. This is nothing but an existing system. What is this? It is an existing system, a current system. So in the real time, now we are processing the data using this approach. Okay, if you see here, we have some different kind of sources like a CRM, ERP, your finance, your social media, your satellite, anything who are sources who will send the data, who will produce the data. Okay, those can be a program, those can be a machine, those can be any device who produce the data. Okay, we will get the data. The data is raw data. What data it is? It is a raw data. Why we are calling this a raw data? Because it just producing or it just coming from the source. There is nothing is happening. It just produced. It directly coming from the source. So that type of data we'll call as a raw data. Then so the raw data you cannot directly go and store into somewhere, and we cannot access, and we cannot retrieve the results on the raw data. It's a very simple example. So let's take the data is coming from the source and you're putting into a database and you start generating the reports. So it has to go through so much of process. So to make you a simple understanding, anything the raw items, any raw items. Let's take an example of paddy or wheat. Paddy or wheat. The paddy or wheat directly coming from the fields. We cannot take and cook them and eat, right? Or we cannot prepare the food out of the raw. So what we will do? We will process it. We'll take them to mill and we'll ask them to process it. We'll ask them to peel off the first layer and polish and all those things, right? So it has to go through some process. Then only we can use for the food and all. The same way here, the raw data we cannot directly use it. Okay, so because the raw data contains the necessary things and unnecessary things. The raw data contains necessary things and unnecessary things. What we will do here, and we have to remove unnecessary things which we don't need it, which we don't need for the reports, which we don't need for the final result. Okay, what we will do, we will do we will extract the valuable information from it. We will extract a valuable information from the raw data, and will apply some transformations. Transformations means, so how can I say, like applying some logic on that data and loading that data into a database. That processing that raw data is called ETL. What is that? ETL. ETL means extract, transformations, and load into a data warehouse system. Before loading into a data warehouse system, we will apply the normalization. What we will do? We will apply the normalization. Right? So what is the normalization? What is the normalization?
Removing the duplicates
Yeah, removing the duplicates and keeping the
and bringing
accurate.
into the commercial.
Yes,
Yeah.
and we will
Bringing
load
into
it.
the commercial.
Yep, and we will be keeping it into a data warehouse system. Okay, so after ETL, we will keep it in a table format. So data warehouse system, if you guys are aware of the data warehouse system, it's a very simple. If you not understand, just think that the data will be loaded into a place where it will be there in the tables and views format. Why we are keeping the tables? Because we have a language called SQL which will support the structural data, where you can easily query the data which is there in the table format. We can generate the reports. Okay, after applying the form normalization, we will load it into a traditional warehouse system. Then we will connect to our the data warehouse system to generate the reports. Any doubt here till here? How the data is coming to our traditional house system? Any doubts?
Oh, it's okay.
The new candidates like Ganga Singh and Sunil.
Data
Oh, it's
from
okay.
different sources.
Could you please repeat, Sunil?
Data from different sources.
Yeah, data from the different sources. Different sources means for your application, it may be a single source. It may be multiple source.
This one application machine, something like that.
Correct. Let's take an Amazon. Okay, Amazon wants to improve their business. What they will do? They want to do some campaign or they want to do some promotions. What they will do? They will collect the data from the different sources. They will collect the data from the retail. They will collect the data from their websites. I mean websites in like social media, and they will collect the data from their e-commerce application. So all the data they will collect from there, and they will process it, and they will understand. Right? And so based on the season or based on the area, based on the data, they will start promoting how the big billion day came, how the this Amazon. So based on the season, they will start promoting, right? The same way, even in the traditional approach, we'll collect the data from the different sources. It can be a single source, it can be a multiple source, and we will go through some process to clean up the data. That process is nothing but ETL, and we will load the data into traditional approach or traditional data warehouse system. Why we are loading into traditional warehouse system? To generate the reports. Generating reports is pretty simple if you have a data in the table format. That's the only thing. Okay, if the data is available in the traditional system, what we can do simply, we can easily we can easily produce the reports. We can easily connect to the data warehouse system where I can send a queries. A data warehouse system is a OLAP, online analytic process. So what I can do, I can just send a query, get the results, and display in the visualization. So that visualization part can be any of our reporting tools. It can be our Tableau, it can be our so there are so many tools are available. Okay, then those reports will be using by your database or administrations or business analyst or business user who is going to improve the business. Clear how the traditional approach is working?
Yes.
Okay,
Yes,
now
clear.
so then why we need Hadoop? It's working fine. So I feel this approach is pretty much good. This approach is pretty simple. Why should I need Hadoop here? What is the problem I'm facing with the traditional system? Why should I move to Hadoop? Now I will show you that. So uh, let me draw something here because I have to explain something. So that's why I thought to take that. Different sources. These boxes are nothing but different sources. It can be a financial institute, it can be CRM, it can be ERP, it can social media, it can be sensors, anything. Okay. So from there, what we will do? We will take the data. We'll take the data. It can be it's raw data, and we'll go through a process called ETL. We'll go through a process called ETL, and we will load the data into data warehouse system. And we will load the data into 1 second, guys. It's so just so from here we will load into a data warehouse system. Where we will load into a data warehouse system. So what is the problem? It's working fine, right? So I can have a visualization system here which who can connect to my data warehouse system to produce the results. I mean to produce the reports, right? To produce the reports. Okay. So this is my DW. DW is nothing but data warehouse system. This is my client. The client or your reporting machine or report generating machine. Here the reports have been generated. The reports using by a business analyst or business users or your data analyst or data warehouse system people, whoever it is. Okay, so this approach is pretty much good. So what is the problem? So let's say and little get into a deeper level. So when you send a query from your client machine, visualization machine, when you send a query from the visualization machine, let's say it's a select query. Why select query? Why can't it be update or something? Because I want to produce the report based on the data. I don't want to update anything in the data warehouse system. I don't want to modify anything in the data warehouse system. I just want to get some data. Based on the data, I want to generate the reports. So when I send the query, what it will do, it can be your data center, it can be your anything. So it can be your data center. It can be your data center. It can be in USA. Let's say it's there in USA. Okay, from when I query the data, it will start downloading the data towards your client, and it will start downloading into your client, and it will apply the logic on that client. After downloading the data, it will apply the data. Why? Because the data need in this client machine to apply the logic. The data need in the client machine to apply the logic. Okay, so we, so what is happening? It is getting the data from a different location. Even though we are on the same network, it has to download some data to a client machine. Then it has to apply the logic. Right? This is the approach we're following. This is a pretty much good approach when you have a less amount of the data. When the data increases, let's assume that my data is increased. My data become huge because this approach has been designed decades before. It means 30 years or 20 years, 30 years before this approach has been created. Those days the data was very less. So in the 80s, if you take in 80s, 90s, the data was very less. So those days, this approach is better approach, best approach I can say, because those days the less amount of the data, your ETL or your RDBMS can easily process it and easily can generate the report. And those days also there is no this much, the technology is not grown this much, and there is no this much competition, right? So now all of a sudden the technology has become user friendly, number of users are increased, and everything has become very easy to everyone, even the layman can able to access it. And so the data is getting produced a lot. Data is data has become it become huge. Now the data is coming from Facebook. If you take a simple as a Facebook an example, 100 TB per day. And if you take a YouTube, every second 40 hours of video, fresh 40 hours of video they're uploading every 1 second. And you can assume how much data they're producing. Twitter, right? Your stock exchange, a stock market. So they're producing a lot of amount of the data. So what these guys are doing, so who are into that business, they're making use of the data to improve their business. They're making use of the data, and they're processing the data, and they start improving their business based on this. So here the problem is, when the data grows, you have to go with a better ETL tools. You have to go with a better ETL tools. So ETL tools are like Informatica or Oracle BI, or there is Talent. These are all, it's not the open source. Those are licensed, where you need to pay money, where you need to buy a license for 100 users, where you need to buy for 100 or 1000 users, right? The very first limitation is cost. And here I need to invest something. When the data grows, I need to invest on here as well. I need to improve my data warehouse system, because my data warehouse system can store a limit amount of the data, right? So to store the huge amount of data, again I have to replace with a bigger machine. I have to replace with a bigger machine. I'm making mute guys, and who are all as anyway who are not talking as of now, I'm keeping them mute, and others can whenever you want to talk, you just can unmute and talk. Okay, so when my data is grown, what I will do, I have to replace, I have to go with a better tool, better data warehouse system, or I have to improve my hard disk in this data warehouse system, which is a scale up, which is a scale up. Scale up means you're improving, so upping in the horizontal direction or vertical direction. I think vertical direction, not horizontal. The second one is, the second limitation is, so let's assume that the data is stored here. So if I have stored the data 50 GB data here, so when I'm processing it here, so the 50 GB data has to download towards your client machine to apply this select logic, to apply the select logic, right? The 50 GB has to download into our client machine to apply the logic, and to download the 50 GB data will take some time. To generate the report in a given point of time, it has to download the data to our client machine. Let's assume that to download the 50 GB data, it has taken 15 minutes. Because let's say I have a very high bandwidth in my the same network, in this network, and the data is downloading data is taking 50 GB data to take 15 minutes, and to process on 50 GB data I have to apply my select query. So let's assume that it is taken 10 minutes. So let's say you are a business analyst. Okay, you have selected some fields from this data to this data to produce a report, and you have clicked on the your visualization tab. You have submitted from your visualization. It can be Tableau or something. So then it is taking 25 minutes to load the report. It is taking 25 minutes to load the report. Will you okay with that? Srinivas, Sunil, or Ganga Singh, Supreet, you
No,
are
of course not.
of course not. So we cannot wait 25 minutes to generate the report, right? So the benchmark in the traditional system, even in my current company, even in my current project, the benchmark is 5 seconds. As soon as I load it, my report has to come in 5 seconds. So this is one of the limitation. Why it is taking time? Why time taking? Second limitation is time, right? Why time? Because
Huge data is transferring
yes,
through
the
network,
huge data is getting
downloading it.
transferred from one place to another place, where we do not have a data locality here. Data locality means wherever the data is there, you don't move the data. Wherever the data is there, your process will go on to execute. That's called data locality. In a traditional approach, we are not having data locality. We don't have a data locality. Data locality means, so what I will do, so instead of moving the data from the data warehouse system to my client machine, my logic is there, right? What are the select query I have written, I will send that query to my data warehouse system only. I will send my query to data warehouse system only. Then I'll ask him to execute here itself, in this machine itself. Then I will take the results. That's better. Instead of moving a huge 50 GB data towards the network, and I'll just send the select query. I'll just send my select query. My select query will be hardly 100 lines. Or if it's a nested query, right? Hardly it will be how much? It will be in KBs. It will be in KBs. So what I will do? In the KB, instead of downloading 50 GB data, I'll just upload my KB amount of data. Right? We do not have a data locality in existing system. And also it is a sequential process, a single machine where it has to process sequential. So we do not have a parallel process. What is the advantage of having a parallel process? You can save a lot of amount of time. You can save lot of amount of time. Okay, so I'm not giving the example for this parallel process. You can easily think like, you can take an apple example. If we, in a box, if we have a 10 apples, if I ask one person to pick the apple, so he has to attempt 10 attempts. So if I have a 10 boxes, each box has one apple, and I have a 10 members. If I ask the 10 members to collect the apples, they can attempt in a single attempt. That's why the team working came into picture, right? That's why the teamwork. So who we will assign the specific work to the specific person, they will start doing parallelly. When they do start doing a parallelly, we'll improve the performance, right? So there is no parallel process in the traditional approach. And when I submit a job, let's say I'm applying this select query. When I submit a job, my data warehouse system is failed. My job also will fail. Right? There is no automatic fault tolerant. Fault tolerant means if I submitted a job, okay, so while submitting it's processing something, the source is failed, it means the database is failed. So my job should not fail, it look for the alternative option, like it should look for the backup data. My job should look for the backup data, so that process is not there here. And the sixth limitation is there is no auto duplication. Auto duplication means as soon as the data is get processed, and while loading the data, the ETL should load the data into three different locations, not in the single destination. It should load into three different destinations. That approach is not there. So these are the limitations we are seeing with the traditional approach. Ganga Singh, are you able to follow? Sunil,
Yes, sir.
you are able to follow, right? Any
Yes.
doubts?
Yes, sir.
Okay, so please don't wait till finish the explanation or till finish my slide. So please ask me the doubt whenever you get a doubt. So if you get a doubt,
Sure.
immediately you can go ahead and ask. So don't wait till I finish. Okay. So I love to hear
Sure, Rohit.
from you guys. Okay. Okay, Ganga Singh. So how about you?
Sorry.
How about you? So do you have any doubt?
No, no doubt. Little bit. One question only.
Go ahead.
Actually, you told me that there is no parallel processing in SSAS.
Hmm.
I don't know much about SSAS, but I'm working in SQL Server,
Hmm.
and there is a parallelism.
So it
I
means
mean,
that you're,
if we,
do you have a multiple missions? You have a cluster environment in SQL?
yes,
Okay. So I think you are using
or
the
uh,
MySQL or Oracle.
SQL Server.
SQL Server. Okay. So that,
Yes.
so how many machines are there? How much data are handling?
Uh, uh, Approx 400 GB.
400
So
GB. Okay.
yes. No, but it's I think default features of SQL Server that whenever we execute any type of query, then parallelism is occurred on that query.
Parallelism. So now the data will be a single location, multiple location.
It's from single location.
So if the data is in a single location, how the parallel process will happen? The parallel processing you might have
No,
telling me.
it's
Yeah, go ahead.
yes.
Go ahead. Go ahead.
Yeah, I think what I understand about parallelism is depends on a number of CPUs.
Correct. So you're talking about you have a 7 core, 8 core, 10 core. That's what, right?
Yes, yes, exactly.
So
Yes,
that is even a single machine, right?
right.
So in a single machine, you're talking about multiple cores, it will be executing the multiple processes, but I'm talking about multiple machines with the same cores. I have a 1 TB data. I want to process 1 TB
Okay,
data with the multiple machines. In the multiple machines, I have 100 machines. All 100 machines can launch 100 into 4 jobs. If it's a 4 core,
okay, right,
400 jobs can parallelly process. It will improve the 400 jobs can parallel execute, which will improve my performance.
right.
And
Got
Right.
your
one more
point.
thing,
I come
one
to a
more
point.
thing is
Yeah, go ahead.
in case of SQL or data warehousing, it is always single threaded. Your single query will be run by a single
Correct.
CPU. It will not
Correct.
be shared.
It will not be shared. Clear, Ganga Singh?
Okay, got. Yeah,
Okay. So these are the limitations we see. These are the limitations we see here in the traditional approach. To to solve this problem, okay. So before getting in it, who is causing the problem here? It was working very well before. Now it is failing to do something. Because of what? Who is the culprit? Who is that creating a problem? Who is
Data.
causing the problem?
it's a huge data.
Huge
It's a
data.
data.
Sources.
Yes.
Can I say it's a big data?
Yes, sir.
Okay, let's move and ask. Let me ask a set of questions here now. Okay, so let me go move the next slide. What are the drawbacks of the traditional approach? It's expensive, it's not that much easy to scale, scalability and time consuming process, right? That's what we have just discussed. It's a expensive, and it's a time taking, and it's not scalable. Parallelism, those are all come into picture. Now, who is causing the problem? Big data, right? What is the big data? What is the big data? It is a huge amount of data which cannot store and process using traditional approach in a given time. In given time, that's more important. So there may be machines who can store the data, who can process, but when you submit a query, it may take 2 hours, 3 hours to generate the reports, or 2 3 hours to process the whole thing. But that is not what we are expecting. In a given time, 5 seconds or 10 seconds, I want the report, right? Right. So if you say a huge amount of data, how much huge, Sunil? If you say a huge amount of data, how much huge? So can I say 100 MB as a big data?
No.
Why, Sunil? Why can't I say 100 MB is a big data?
Nowadays 100 MB is not a big data in terms of GB, TB.
Okay, with respect to what? You're talking with respect to what? 100 MB is not big data. You're talking about with respect to traditional approach, right? So with the traditional
Yes.
approach, 100 MB is not a big data. Let's take a simple example. So can you send a 100 MB file through an email? Can you send an 100 MB a file through an email?
It's a big data.
You cannot send, right, Sunil?
No, we cannot send through mail.
Through email. So for that email application, the 100 MB data is a big data, right? It means my email
Yes.
server is failing to handle 100 MB file, right? My 100 MB is my email server is failing to handle 100 MB data. So for my email server, the 100 MB is a big data. Okay, understand? So when you say big data, there is no limitation. When you say big data, there is no limitation. There's like this much amount of GB data or this much amount of TB data, I'll say big data. So in a current system, using current system or traditional approach, if you are failing to process or store some amount of data, that data we can call a big data. That can be 100 MB, that can be 1 GB, that can be 10 TB, whatever it is. Petabytes or zettabytes or octabytes, right? So that's the actual definition of your big data. It's a huge amount of data which cannot able to process, and it's not able to store and process using traditional approach in a given time. That's a proper definition for a big data. Okay. Okay, there is no don't say like it's a 1 TB data, I'll say big data. No, there are some systems who can store and process 1 TB data, but that may take the time taking process.
Yeah.
Okay. Okay, if you say the data, how the data is, how it is grown, the data in 80s it was the kilobytes, and 90s it was a megabytes, and 2000 and 2010s it's moved to GB to TB. Now we are in petabytes of data. In the current situation, we are getting different kind of data, different kinds of data, right? To process, it's getting as unstructured, it's getting as structured, we are getting the semi-structure, all type of data we are getting. Understand, Sunil? Venkat?
Yes, sir.
Venkat?
Yeah, yes, Ravi, we understood.
Okay. And so if you see the classification of the data, that it has been classified into 3 forms based on the data it appears and the schema it follows. It has been classified into 3 different structures, 3 different categories. So one is the structured data, another one is the semi-structured data, other one is unstructured data. Structured data means when you look at the data, it follows the specific delimiter or specific schema, like your database tables, like your Excel sheets, like your CSV files, like your TSV files, who has a proper structure. You can send a query, get the data, or you can process that if you easily process the data. Or when you compare the same kind of data with other sources, the data looks similar. The data looks similar format. If you take MySQL table, if you take a Postgres table, if you take Oracle table, all tables are similar. All will have a columns. If you take a MS Microsoft Excel sheet, and if you take Ubuntu open source open office Excel sheet, all looks like a sheets only, like a columns. Your CSV files, your tab separated files, your common separated files, all will look like a similar. That's the structured data. When I say semi-structured data, before getting into semi-structured, let me finish with unstructured. So unstructured data, the best example is your audio, video, images, which will not follow any structure. Those are the best example for unstructured. If you might have read somewhere here and there, like your text files or XML files are also unstructured data. So the people, what they have done, they have categorized only two categories. One is structured, one is unstructured. When they categorize only two categories, then all the semi-structured fall under unstructured. If they categorize three categories, so the semi-structure, your text files and your move and JSON, the XML file has been moved to semi-structured. Why? Because the structured data you can easily process. Unstructured data you cannot process, but you have so much of other techniques to process. But semi-structured, after struggling a little bit, you can process. That's why it has been categorized three. If you find any blog, if you find any books or anywhere in the online, if you find text files or log files are unstructured, it means that they are referring only two categories, structure and unstructured. Clear? I'm just jumping to other slides. I don't want to kill others time because already others has gone through it. Okay, there are some categories, characteristics of the data. So volume, velocity, variety, veracity, and value. There is a one is missing here, variability. The first volume is V says that volume, how much huge amount of the data we're handling, and second one says that velocity. The velocity says that how fast the data is generated. What are the data we're handling, how fast the data is generated. And third one says that variety. Variety means what type of data, different kinds of data, structure, semi-structure, unstructured. And veracity says that how accurate the data is, how trustworthy the data is, how good the data is. And there is one more V, which is variability. Variability says that today my source is giving me structured data, tomorrow it may give semi-structured data, and later after some days it may give unstructured data. So my setup, my cluster should be able to handle, my design should be able to handle all type of data anytime. It's not like today I'm supporting only structure, tomorrow if you give me a semi-structure I'll not support. It should not be like that. So your Hadoop setup will handle any type of data. It will store any type of data. The final one is value. Value is a very much important, it's a more important thing. So because we are doing something means it's for a value, right? So if they are processing some data, they'll get some value. That value they will, by using that value, they will improve their business. It means it will added a value to their business, right? That's why they're processing huge amount of the data. They're investing so much of things in the environment and the development, the processing the data, right? So let's move. These are the definitions. Anyway, that this document I'll share with you, so you can have a look. Different kind of sources from where and all you can get the data. You can have healthcare missions, you can have sensors, you can have satellites, you can have financial institutes, you can have social media. So there are different sources how they'll get the data and how fast the data is generating. Okay. And variety, volume. Now, how important that big data is. So our business market, security and law enforcement, improving the healthcare, improving the sports, avoiding human diseases, future predictions. So many things are there. All with these things can be processed. We can get a benefit out of a Hadoop, right? So we just know about the data. Okay, still we didn't see the solution. We just has gone through the problem statement, and we just saw the who is causing the problem. So now we'll get jump into our data. So it's an important a funny slide it is. The slide says that at the end of the day, big data provides an opportunity for the big analysis, leading to a big opportunities. What it is doing? So if you give a big analytics, what will it's give you a big opportunities where you can promotions, where you can do a promotions, where you can get the huge market, where you can capture the market for your business, and to gain a competitive edge in the future world, to to advance the quality of life, to overcome the limitation of a traditional database. Right? So what is the conclusion? Learn big data, earn big salaries.
Yeah,
Right?
that's what we need.
Right?
Are
At
you
the end,
sure?
we need that only, right?
Yeah.
Yeah, of course.
Okay. So that's the conclusion of big data. Let's move to Hadoop. Then how we'll solve the problem? Now, what are the challenges we have seen with the traditional approach? It's a huge. I mean, what are the challenges with the big data? If you have a big data, it is very difficult to storage, difficult to manage, and it is difficult to process efficiently. I mean, it doesn't mean
Okay.
that it will not support, it will not, I will not do at all. It means it will do, but it will take. It's not efficient. It's not that much efficient, right? And so it's difficult to process the extract information from the huge amount of the data. It will take so much of time. The solution is Hadoop. The solution is Hadoop, right? This elephant is so cute, right? Even Hadoop also that much cute only. It is pretty simple language. You can easily learn it and you can easily earn it. But you should need to put some efforts because we are not from that background. So we need to put some efforts to learn a big Hadoop. Now don't say my personal suggestion is that once you learn Hadoop, okay, don't stuck there. Nowadays a trend is going like up direction. So many new tools are coming into market. Today I have learned Hadoop. Based on the Hadoop there are so many tools like a Spark, there is a Mahout, there is a Flink. So there are so many tools are getting. So try to keep an eye on them. Try to keep an eye on them because tomorrow all of a sudden your organization thinking to change from Hadoop to Spark. But it works based on the Hadoop only. It will work on top of the Hadoop, but still you should know that advanced things. So if you say let me take in Java as an example. So initial days for the processing web applications, we have a servlets and JSPs, then struts, then springs, then web services. So then so many new tools are came into, right? So the same way, but it's based on the Java only, based on the core Java only. The same way here, it's based on the Hadoop only. There are so many 250 tools are there on top of it. So no need to learn all the tools, but just keep an eye on the famous ones like a Flink, like your Spark, like yeah, Flink and Spark are the top things as of now. Okay. So
Okay.
once you completed the
Okay.
Hadoop training, so let's keep an eye on it. Anyway, I'll give the introduction for the Spark. I'll help you. I'll make you familiar with the Spark. You can go ahead and learn yourself
Okay.
easily. You don't need to go to any institute. You don't need to attend any classes.
Okay.
That'll make you pretty simple. Okay. So what is the definition of the Hadoop? Hadoop is an open source Java-based framework that supports storing and processing large data sets in a distributed environment. So if it is a distributed environment, what is the advantage? The performance, right? Fault tolerance. So all these things will come into picture. We'll just go ahead and look at them. History. So I don't want to spend more time on this. I'll just no, I'll just take you the history of this very simple way. Let me show you that. So in 2002 and 2003, there is a person called duck cutting. This is the guy who is playing with a yellow elephant toy. He's a duck cutting. So this guy is a freelancer. What he started his own project called Nutch, N-U-T-C-H, which is a web search engine tool. And he stuck in the 2013, I mean 2002, he stuck with some problem, the big data problem, and he was not able to process it. Then in the same time, there is a Google. Actually, the origin of the Hadoop is Google actually. Okay. The original origin. I'm talking about the original origin. So Google in 2013, the Google 2003, sorry, 2003, the Google has launched a white paper. It is a white paper, guys. The Google don't want to share the source code. Google is just like a selfish. They don't want to share the source code. And 2003, 2004, in between 2003, they have launched a white paper saying that if we have a big data problem, we can process that big data problem in a GFS and MapReduce. Using GFS and MapReduce, GFS Google file system, we can solve that. They just given the abstraction. And 2004, the duck cutting, what he has done, he has gone through those papers and he understand. He started implementing himself a new file system that is become a Hadoop file system, Hadoop distributed file system. Okay, and duck cutting added the DFS and MapReduce support to a Nudge. Nudge project is become good. I mean, it's become very popular. Then in 2006, what happened? This duck cutting has been hired by the Yahoo. Yahoo is the company. He's hired the duck cutting, and they have spent so much of amount of time and amount of money on the Nudge project because it looks very simple. It looks very easy to process the large amount of the data. They spent a lot of amount on the Nudge project. Finally, the Nudge is become a Hadoop in 2006. When it so they have so why they have named it as a Hadoop? It's very simple. The duck cutting son was playing with a yellow elephant toy, yellow color elephant toy, and the kid who used to call, the kid is I think 3 to 4 years of old, and that kid used to call that elephant Hadoop Hadoop, and they have named it as a Hadoop. So the pretty, there is nothing a technical things behind the name. Okay, they just named it as a Hadoop. And 2007 they have started doing an experiments with the New York Times, like how we have India Times. The same way New York Times, they have converted 4 TB of data in over 100 EC2. EC2 means elastic cloud computing. I mean 100 machines. And 2008, Hive also facing some problem. Sorry, not Hive. Facebook also facing some problem. They were not able to process a huge amount of the data in 2008 till 2008, and they were using SQLs. They were using SQL to process the whole huge amount of the data. So every day they used to end up with a very big queries and the very complex queries. Okay, then they understand the Hadoop environment, Hadoop architecture. Then they have designed a tool called Hive, Hiv, Hive tool. That Hive tool supports SQL because those guys are SQL developers, and they want an easy tool to process the data. They have designed a Hive tool in 2008. And in 2008, Yahoo has again tested one more thing, the first test, sort algorithm. They have applied some sort algorithm in a TB data in the 3.5 minutes in over 1,000 nodes. They have processed the sorted the data. Sort is a very big costly algorithm. Sort is a big, I mean, which is a complex algorithm. If you guys, so which is a random data. So if you sort the random data, how to compare each and every element with the respective element. So they have done that in 3.5 minutes in a 9110 nodes. Then Cloudera has been founded. Cloudera in 2008 it has been founded. So the Cloudera is something called see, this has been donated to Apache. Okay, in 2006, what these guys has done, the Yahoo has been created the project, and they have donated to Hive Apache, and then it became an open source. Then everyone started taking that, contributing like a sponsors. It's like a Facebook, like Yahoo, like so many people are shown interest, and they have started doing experiments. Like a Cloudera also get founded in those days. And what the Cloudera, the beauty of the Cloudera is, so if you go with a plain Apache Hadoop, you have to install everything. You have to do all the configuration yourself. So you'll go through the pain. But what the Cloudera says that you no need to do anything. I'll give one bundle which is called a VM, Oracle VM, or not Oracle VM, Cloudera VM, a bundle. You just install that file. You'll get all the softwares available in it. They have customized it. They have a Cloudera manager to manage the cluster. You don't need to do through commands. Everything you can do through UI. So that kind of customization they have provided for the Hadoop, and they have named it as a Cloudera, CDH4, CDH5, like that. They have named it. The problem with the Cloudera, even that is an open source, they have, because they have customized it, if you face any problem with any of the component, like your pig or a hive, or if you face any problem in that CDH, you have to approach Cloudera only. You have to approach Cloudera only. If you approach a Cloudera, they will ask you to pay. Even though it's an open source.
Ravi,
Yeah.
Ravi, 1 minute. Cloudera will give with space and all type of components like Hdfs, map reducing related, Hive, Pig,
Yeah, Cloudera will
space,
not give a
everything is
space.
contained.
Cloudera will not give a
Okay,
space. Okay.
okay.
Cloudera
Just
will
the
give you a
framework.
software, correct, a framework.
Okay, okay, okay.
Okay. But
It's kind of in case of .NET or in case of Java, you have that Eclipse to integrate or
yeah, Eclipse is the
your Visual Studio kind
IDE.
of thing.
Actually, Eclipse is
Yeah.
IDE, right? So in case of,
Okay.
when it comes to Java, like
Uh-huh.
Sun Java, Oracle Java, like Open, some different kind of
Okay.
Javas are there, right? Just like that.
Okay. Okay. Okay.
Okay.
Fine. Yeah. Fine.
So, but it is also open source, but it is chargeable when you go for the support. Something is not working in, suppose you have downloaded Cloudera, you have installed on so many machines, and you are starting doing some jobs. So job is failing due to some
Okay.
unsupported things. So when you go and ask them it is not supporting, then they will ask you to pay.
Okay.
The support is chargeable. Okay. And they have done so many experiments in 2009. Still they are doing so many experiments. So that's the history of Hadoop. So are you guys clear? Any doubts?
Yeah. One doubt started now. This big data started at 2008 itself. Even we have started our career in 2008. Why we didn't into big data?
Okay, see that's the reason. So India, it came to Indian market, as per my knowledge it is 2012, properly known. I mean, there are some people who are using, because the clients, they were having some clients who are in US, they were working for them, but that time in 2006 2007 it was there. But in 2008 2012, in between this time, so even India market also started adopting it.
Okay.
That's why even it's a very good time to get into as soon as possible, because on this Hadoop stack there are so many tools are getting implemented. So many tools, guys. Whether you guys believe or not, there are 250 tools on top of it. 250 tools. So more than that. Every day they're getting a new tools.
Okay.
Okay. So not only for the ETL. See, this Hadoop will support ETL. Not only ETL. It will support OLAP. So the ETL things, like you can do by using any technology like MapReduce, Hive, you can do anything, and it will support so many other things like OLAP. You can create a database. You can create a database with a multiple dimensions. You can create a database with star schema. So I'm very new to those technologies, but I'm seeing in my current project. So you have so many tools. Druid. There is one of the tool. I surprised. I never know it. Druid, Drill, which is a Pestro. There are SQL engine. Pestro and Flink, Spark SQL, Spark MLib, Spark Xgraphics. There are so many tools are coming into a market, but all are based on this technology only. All based on this thing only. Okay. So
Yeah.
Ganga Singh, are you able to follow?
Yes.
Okay. So still we're not yet seen the solution. We'll just go ahead and see the solution. So how it will work, and this is a brief history. So you get just 2002 what happened, 2006 and 2009 what happened, just an history. And this is job opportunities. Yes, there will be so many of job opportunities. You not at all worry about it. You might have heard about the how the big data is ruling the world now. So this is a simple example how the jobs are increasing. Okay, and these are the different kind of roles you can become. You can become a Hadoop developer. You can become a Hadoop administrator. You can become a Hadoop architect. If you can also become a data scientist. To become a Hadoop administrator, You should be very strong in the network, and you should be very strong in the support kind of things like Linux installation, Linux command, Linux scripting, scheduling jobs. So you should be very strong in that area. So if you want to become a Hadoop developer, you should be strong in the MapReduce, Hive, Pig. So these are the processing things. And to become architect, yes, you guys know what is architect role. And to become a data scientist, you should be very strong in the statistics analysis, and you should be very strong in Python or R, some machine learning languages. Okay, these are the different titles or different roles you can get in a Hadoop. Clear, guys? Okay, let's move. Before moving to concepts, I just want to explain how the Hadoop works. Okay, so we just seen what is the problem. We just seen what is the so let me show you how Hadoop solve the problem. So Hadoop come up with the beautiful components called HDFS and MapReduce. Hadoop come up with the two beautiful components called HDFS and MapReduce. One is the HDFS, another one is a MapReduce. Hadoop HDFS is for the storing the data. It is called Hadoop Distributed File System. HDFS means Hadoop Distributed File System, and MapReduce is map and reduce. Okay, so HDFS is mainly meant for the storing the data. MapReduce is mainly meant for the processing the data. MapReduce is mainly meant for the processing the data. HDFS is mainly meant for the processing the data. So is clearly showing that HDFS is a file system. It is not a database. It is the file system. Hadoop distributed file system. Okay, how Hadoop distributed file system works. So before that, we should understand how the distributed file system works. How the distributed file system works? You will be having a multiple sources or destinations, whatever you call it, multiple machines, and you will be accessing that machine from the single path. Right? You will be accessing that machines from the single path. So you will be seeing the shared drives in your company. Right? We'll be seeing the shared drives from our company. So there will be a shared location, and so many people will be sharing to that location, and will be accessing a client. For the client, it is a single file, single location. Am I right? Suppose your friend has shared something. So how will you access in your company? You will go to run command. There will access something. Right? You will give some path as a shared path. Then it will list out all the availabilities. It will list out all the available sources, and wherever you have authentication, you will just go ahead and look at that. That's the way the distribution file system works.
Yes.
Right? So it means that the dedicated machines will have a dedicated software. Let's say this machine is handling only employee, so it will handle only employee. The student, it will handle only students. The projects, it will handle only projects. So for the client, even though these are multiple machines, so a client has a single entry. The client has a single entry. So that's a distributed file system. So the client should have access to authentication to access all these three machines. And suppose when you want to process employee, you can process only single machine. So what is the problem if it is a single machine? No parallel process. If this fails, no duplication. Right? If while processing this fail, the job will also get fail. Right? That's the problem with the distributed file system. Now then, how HDFS works? Then already I have a DFS. Then why should I need HDFS? The HDFS help you to solve these problems. Let's look at how it will solve the problem. HDFS follows an architecture called master-slave architecture. The master-slave architecture is nothing but like our team. So who is the manager? Who is the master in our team? Who is the master in our team?
Name node.
No, not in the cluster. I'm talking about in a team. In a team, in the day-to-day life, in
Manager.
our manager, right? So
Supervisor.
supervisor. So manager is our master. So what our master will be doing? He will be managing the team. He will be monitoring, right? In the same way, here HDFS also follows the master-slave architecture. Master is your name node, I'm typing NN, so I'll write it here. Name node. What is a node? Node is a physical machine in the network. That's it. So there is no big difference. I mean, big definition for it. So data node. Data node. So it follows the client server architecture. Sorry, master slave architecture. The master is our name node, and the slaves are data nodes. So who is the slaves in our team?
Team member.
Team members. So is your manager actually do the development work, testing work, or some kind of work? The manager is mainly meant for the managing the team, so he's not meant for the development. So development can be done by the team members, then why you, right? So manager has he has enough work to do with other things. So there are some technical managers and pure PMP managers and technical managers. I'm not talking about technical managers, I'm talking about normal managers. Okay, so the managers, they're mainly meant for maintenance the resource and to manage the project and all, right? The same way here, your name node is a master who is mainly meant for managing these guys. So here I have taken only 4 machines as an example. In the real time it will be hundreds of machines, 40, 50. It's almost in the hundreds of machines. So based on the work, based on the data, based on the data how much you process. So those machines has to be processed by name node, right? How it will process, what are the things it will do? So it will identify whether the machines are alive or not. It will identify whether the which machine is doing what. So it identifies what machine is doing what and what machine is stored what data. Like our manager also identifies, okay, uh, Sunil is a .NET developer, and let's say Srinivas is data background, and let's say some other Ravi is Hadoop developer. Let's say take some example. Venkat is ATG. So you'll identify all the resources he'll manage, right? The same way your name node also maintains a metadata, and the name node also maintains the metadata to keep track of all these guys. To keep track of all these guys. Okay, every 3 seconds these data nodes will be keep sending a block report, or sorry, a heartbeat. Every 3 seconds these guys will be reporting to a name node saying that I am alive, I am alive, I am alive. Every 3 seconds. Okay, otherwise your data node will not understand whether he's there in the network or not. You'll just send a signal. Okay, your machine just send a signal, I am alive. Okay, so
Yeah.
based on that signal your name node understands that. So your name node is meant, actually your name node is not meant for storing the actual data. Let's say I have Amazon data. Let's say I have Amazon data. So the Amazon data is, I want to store Amazon data into the cluster. So the Amazon data will not get stored in your name node. The data nodes are mainly meant for the storing the data. How the data will store in the cluster? The data will store in the form of blocks. What is a block? Block is a chunk of data, a piece of data which will store in the single machine, or which will store in different machines. A chunk of data. Suppose I have 1 GB data here. Suppose I have 1 GB data here. I want to process this 1 GB data. First, what it will do, it will break this data into pieces, chunks. Those are called blocks. Even guys, even the local file system also, this is what happening. Even your disk reading or disk writing also, this is what happening. Okay, the whole data will be break into pieces. That's called blocks. The pieces are called blocks. Block 1, block 2, block 3, block 4. So if you compare with the local file system, in the local file system the block is 4 KB or 8 KB. The 4 KB, the block is 4 KB in the local file system. But when it comes to Hdfs, Hadoop, when it comes to the Hadoop, the block size is a very bigger block, guys. 64 MB or 64 or 128 MB. So Hadoop 1 version, it's a 64. Hadoop 2 version, it's a 128 MB. And not only that, so your Hadoop also follows, there is one more thing called replication factor. Replication means how many copies you want to store. By default, this is 3 copies. You can go ahead and modify, guys. It doesn't mean that you cannot modify. Your 64 MB, your 128 MB, these things you can modify. Okay, the replication factor also you can modify. The replication factor also you can modify. Are you guys able to follow?
Yes.
Okay, so if you guys keep quiet, so I may get doubt whether it's disconnected or it is still continuing. So please, please
Yeah.
respond to me. Okay, okay. So this 1 GB data will be split into blocks. How many blocks will come? 16 blocks will come. Okay. So now what will be do? There will be a client. There will be a client like our client in our company. So what the client will do? The first client will pick the very first task. Client will first pick the very first task like a block one. He will go and talk to the data name node, because your client never knows where the data nodes are there. How many data nodes are also there, also your client never knows it. Okay, your client knows, okay, I want to store this data, let me go and talk to manager. The same way, the block one, he will take the block one, he will go and talk to the name node. He will go and talk to the name node. Will tell that, hey master, I want to store this data, this is a 64 MB chunk, and the replication factor is 3, and give me 3 machines. And this guy will identify his metadata, he will refer his metadata, who are all free, like our manager, right? So when the new task comes, our manager will refer his excel sheet or his excel sheet or his time, whatever the sheet he prepare, and he will identify the missions, right, who are all free. He will identify the resources who are all free, like Venkat and Srinivas and Ravi, these three guys are free. Okay, let's assign the task to them. The same way, the name node will identify the resources who are free, where and all the data is space is available. Not only that algorithm, guys, it follows, there is an algorithm called rack awareness. Rack awareness and block replacement policy, there are two things which will follow, and based on that, your name node will return this guy to, okay, you can go ahead and store your block into mission 1, mission 3, mission 4. Okay, and also it will give the IP addresses in a sorting order, guys. It will give in a sorting order based on what? Based on the distance. Based on the distance, your client can be in the client also will be the network, right? Whoever is near to the client, whoever is near to the client, it will give that mission first. It will give that mission. Let's say the the client mission 1 is very near to the client, and the mission 4 is, mission 3 is next, mission 4 is next. So the same way, your name node will give in a sorting order. It will give in a sorting order. Then once your client identifies the data nodes, he will go and connect to one mission only. He will first connect to the mission 1, because he don't want to connect to all the mission. He will first connect to mission 1, and he will tell to the data node 1, you go and connect to 3, and he'll tell that you go and connect to 4. And the block 1, so till here we're processing block 1 only, we not yet come to block 2, right? So block 1, now the block 1 will be passed to this guy. Block 1 will come here, the block 1 will come here, and the same block 1 will move here, the same one block 1 will move here. It means 3 copies, the same data has been copied into 3 missions. As soon as the data is stored here, these guys will tell to the name master, saying that, hey master, client is assigned some work to us, we are doing on it. So he will give the report to name node, saying that we are stored this block successfully. Then what your master will do, he will make an entry. What is the file name? Amazon. What is the block? B1. Okay, so B1, where and all it is stored? 1, 3, 4. So the same thing will be the block 2. Now client will go to block 2, and your name will make a mark of block 2, and here the block 2. Block 2 is stored, let's assume that 1, 2, 3, and block 3, let's assume that 2, 3, 4, and block 4, let's assume that it is again 1, 3, 4. Block 5, let's assume that it is again 3, 4, 5, what it is, 3, 2, 4, whatever it is. Okay, 3, 4, 5. So what it will do, it will maintain the metadata in this form. It will maintain the metadata in this form. Why it is maintaining the metadata in this form? So it will also make a note here, block 3, block 4, and so on. So your name node maintain this. So the first one, this is called file to block mapping. This is called file to block mapping, and this is called block to data node mapping. What it is saying, the file has been divided into these many blocks. The file has been divided into these many blocks. So those blocks has been stored in these many machines. This is called file to block mapping. This is called block to data node mapping. Block to data node mapping. Are you guys able to follow?
Yes, Ravi.
Okay. Now suppose I want to process the data. Now I want to process the data. So now the data has been distributed across the multiple machines. So the Amazon data has been broken into pieces. Those has been stored into all the machines, right? But in the normal distributed file system, if Amazon data, if I want to process Amazon data, I have to keep in a single machine. I cannot distribute into multiple machines. Am I right? Guys, am I right? Suppose I want to keep Amazon data in the distributed normal distributed file system, I can keep in only single machine, right?
Yep.
So but in the Hadoop, when it comes to Hadoop, the data has been distributed across the multiple machines. Same Amazon data, now the same Amazon data is there, mission 1, mission 2, mission 3, mission 4, mission 5. It can be any number of missions based on the cluster size, right? Now let's see, I want to process this data. I want to process this data. When this is getting processed the data, what will happen? The block 1 will process from the machine, this machine. Block 2 will process from this machine. Block 3 will process from any other machine. Block 4 will again process from other machine. Block 5 will get processed from other machine, right? Block 6 will get processed from the machine 3. So it means my data is getting processed parallelly. What is happening? My data is getting processed. One second, guys. My data is getting processed in the multiple machines parallelly. My data is getting processed parallelly. If my data is getting processed parallelly, what will happen? I can reduce the time. I can save a lot of time. And I have a parallel process. I have a parallel process. Do I have a automatic duplication? 3 copies. Automatically 3 copies. Right? And coming to the cost. Ravi, here I am storing 1 machine only, but you are storing 3 copies. 1 GB become a 3 GB here. Then you are improving the cost. Is my Hadoop software is licensed? Do you need to pay anything? Hadoop is a open source.
No. Yeah.
Hadoop is open source. You have reduced a lot of cost. But you may ask, Ravi, instead of 1 machines, you have taken 3 machines. Here, I have so multiple machines. These machines are called commodity hardware. Cheaper hardware, guys. This is cheaper hardware. Like you can get it. Cheaper hardware means, so I'll just give an example for the cheaper hardware. Like 64 GB RAM, 1 TB at more than 1 TB hard disk, or 500 hard disk also chalta, or 500 hard disk also you can take, and 4 core, 6 core, or 12 or 24 core processor. Only these 3 components you need. In a cluster, right? In a cluster environment, you don't need a monitor, you don't need a keyboard, you don't need LED, LCD, 3D monitors, right? What is the 64 GB cost? 64 GB RAM cost ideally in the market nowadays?
500?
No, 64 GB, 64 GB,
GB. Okay.
64 GB RAM. So it will hardly cost, I think, 20,000 as per my knowledge.
Okay.
And 1 TB hard disk,
GB.
1 TB or 2 TB hard disk hardly 4,000 rupees. Even last, I have seen the Flipkart big day sale. What is that? Big billion day sale. 2 TB it's costing 4,300. West side hard disk. And if I go with the processor, yes, processor will be a little costly, like 30,000 or 40,000. So total,
Yeah.
70 to 1 lakh rupees, I'm getting a one machine. 70,000 or 1 lakh rupees is a big deal for a company.
No.
It's a very simple,
No.
very less amount for them, right? So they can easily make a cluster. They can easily make a very big cluster. That's the cost. So we are going to now still, that is if you go and buy yourself. If you go with a cloud like AWS, still it's very cheaper. So you just need to pay how much usage you are doing.
They will maintain the all nodes.
Everything they will maintain. You just need to tell how many machines you want. I want 100 machines, yes, 100 machines. I want 20 machines, 20 machines on the fly. Automatically scale up, automatically scale down, right? So I have reduced the cost also here compared to the previous approach. And data locality. If you see here, my data here in these machines, my process is going and processing each machine, right? Do you see anywhere I'm copying the data from anywhere to process? The data, wherever the data is there, my process is processing that location only. My data is not moved anywhere. My data is not moved anywhere. The data is there machine 1, yes, you go ahead and process the machine 1. Data is there machine 2, you go ahead and process the machine 2. Machine 4, machine 4. So it means wherever the data is there, I'm getting processed that machine itself. That is called data locality. If you see it in traditional approach, you are moving data from the data warehouse system to other machine to process. Correct? Is this clear, guys? So
Yes.
I have data locality also. The next one is fault tolerant. This is very much important, guys. Here, see, I'm processing the block 1. Please observe. I'm processing block 1 in the machine 1. The machine 1 is failed. Still, how many copies are remaining? I have 2 more copies. So when the machine 1 fails, my job will not fail. It automatically spans to the next machine and will start processing in this machine. That decision will take care by your name node. Actually, it's not a name node. It is a job tracker. That decision will take by the job tracker. We'll talk about the job tracker and task trackers. The task trackers will be there in each machine. The job tracker will be there in the name node, or it can be a separate machine. We'll talk about that later. Okay, the decision will take care by the job tracker. Job tracker is a master here, and he will assign the work. Guys, follows? Are you guys able to follow?
Yeah.
Yes.
So, and my fault tolerance also there here. So I don't need to worry about my job. My job is getting processed. So I have automatic fault tolerance also. There is one more advantage here. If I have data is increase, so I no need to stop my cluster. I can just go ahead and add some more machines anywhere I want. I will add some more machines. I'll just give a connection. I no need to stop the cluster also. On the fly, I can add the machine. Automatic scale up. Scale out. It is a scale out, guys. It's not a scale up. Scale up means you're going with a bigger machines. You are replacing a bigger machine again. You are replacing again a bigger machine. So scale out means you're adding the new machines in the cluster. Clear about Hadoop? Okay. So if you guys have any doubt, please let me know. Do you guys have any doubts? Ganga Singh and Sunil, Venkat. Do you guys have any doubt?
No, Ravi, we are clear.
Okay. Ganga Singh, you? I think he's not at. Hello. Okay, Sunil, do you have any query?
Right now, I don't have any query.
Okay, good. So then, shall we move to next topic? Actually, this is what we have discussed in the very first class. So again, I bothered these guys, but still, this is what we have discussed in the very first class. Okay, so next we're going to jump the next topic. So, do you guys want any break? Do you guys need any break? A 10-15 minutes break, then we can join back and we'll continue with
Yeah,
the
we can
next.
have a cup of coffee and we'll start again.
Okay, shall we have a 10 minutes break? So I won't have coffee and all. I'm very much okay to continue, but so it's I mean, it's purely your decision, you guys' decision.
Not required for continue.
Need to leave now.
Can continue?
Office. Yeah, I can continue. We can
Please.
take a 5 minutes, 10 minutes break if that's if you guys want to get fresh up or whatever you want. Okay, so Ganga Singh want to leave. So guys, anyone wants to leave for the day? Supreet, Srinivas, Sunil, Venkat. I'll take
No.
another 1 hour. I'll take another 1 hour only. I'll not take more time.
No issue. We can continue.
Supreet.
I'm fine.
Okay, very good. Thank you. Okay, fine. So let's have a 10 minutes break. Then we'll continue. Fine.
Sure. Okay.
We'll
8:10 will back.
Yes. I mean, record this. Okay, and FS image. Now let me show you this. Now what happened here? The transaction information has written into edits, right? But the transaction information will not understand by the name node. The transaction information is raw transactions. It will not understand by the name node. It will understand by only the name FS image. Are you guys able to follow? Are any guys stuck anywhere?
No. Okay.
No. It's okay. No problem.
Going right. So now, when the name node restarts, the first thing it will read the edits. Read edits and merge with FS image.
Merge with FS image and it will give to RAM again.
Yeah. First it will merge with FS image. That FS image will be loaded into RAM.
Okay.
Clear?
Yeah.
So what does it mean? Every restart, whenever the name node restarts, first it will read the edits log file. It can be a big file, it can be a small file. Then it will merge with our FS image. Then that FS image will be loaded into RAM. Right?
Okay.
So let's see what is FS image here. FS image, periodical checkpoints of the system. Checkpoint means whenever the merges happen. Called FS image. It is a snapshot of the file system when the name node started. Okay, now we need to understand something here about the name node. When in use, all the information is stored in the main memory, but this information also stored into a disk for the persistent storage. Where it will store? In the edit log file. Name node is the central point of the Hdfs and is a single point of failure, right? If this is failure, we cannot access anything. Name node responds to the client request with the corresponding data node IP addresses. So we have talked a few minutes before, right? So that's the functionality of the name node. Then what is the limitations of the name node?
It will become very large. Okay.
So what is the limitations of the name node here? If you see, let's say I didn't restart my cluster for 6 months. What will happen?
It
The edit
will
log will,
log information in RAM itself.
no, not only RAM. I'm talking about even your edit log file.
Edit log files also will keep on grow that.
So your edit log will grow a large. So when your name node restarted after 6 months, all the edits has to merge with FS image, right? Which will take some time,
Yes.
right? So
Yes.
so if it takes some time, it means your restart will take so much of time.
Yeah. Could be commodity hardware can't use for name node.
See, commodity hardware can be used as a name node, but name node always will take it as a good machine. Why? Because so it doesn't mean that you cannot use the commodity hardware. You can use the commodity hardware as a name node, okay? But commodity hardwares are I mean proven that there will be more failures. So if name node fails, there is no point, right? So that's why we'll keep the name node is a bit good configuration. So your restart will take so much of time. That's a limitation 1. See here, edit log become very huge, very large, which will challenge to manage it. Name node restart takes long time because a lot of changes has to merge with the FS image. In case of crash, we will lose the huge amount of metadata since FS image is very old. Understand this point, the third point? If your data node is failed, The FS image is merged last time when it restarted last time. It will not understand the edit log. It will understand only FS image, right? So I have merged it 6 months before. After 6 months, my cluster is down. I mean, my name node is completely failed. I'm not able to recover.
Okay.
But whatever the FS image you have, that was very old one. So whatever the transaction you have done after 6 months, I mean before 6 months, all the data I may lose, right?
Okay.
These are the
Yes.
limitations. Then how to solve these limitations? How to solve these limitations?
Okay.
And on one more point I would like to bring here. So while this is merging, right? While this process happening, edit log is started merging to FS image, right? That time your cluster will be in a safe mode.
You will not be able to access the cluster at the time.
Safe mode means you can able to access for the reading. You cannot write anything.
You can't do any transactions. Okay.
You cannot create a new data. You cannot do any new data, but you can read and process. But process also will not allow, because when you process the data, it will also produce the output, right? The output has to
Oh.
write. You just can read the data. It means you can copy the data from Hdfs to local file system.
Okay.
Okay, clear these points?
Yes.
Okay, now Venkat and others, guys, you guys able to follow?
Yes, Ravi.
So no problem, right? You guys are able to follow, right?
Yeah.
Sunil?
Yes, Ravi.
Okay, good. So let's move to how to solve the limitations. How to solve the limitations. Okay, so we were talking about edit log, right? So the edit log will be created like this. The edit log also says a file. The file will be created like this. So each edit will have the set of transactions. Transaction 1 to 7 is one edit log, 8 to 15 one edit log. So there are some edit logs like this. Okay, edit in progress means, so now the current edits are going on. Current edits are going on, and this is FS image. We'll talk very detailedly on a very few slides. You know, not to worry about it. And your edit logs look like this. Your edit logs looks like this. And edits, edit version, record, and transaction ID. And so what is operation, whether make a directory or create a directory, what is operation, and that the raw information available here. So but your name node doesn't require the operation type, who did the operation, when the operation start. Those that your name node doesn't require that. Your name node knows what is the file, where and all the file is loaded.
Yes.
Okay, so your FS image looks like this. FS image, image version, image namespace ID, where the data is stored, and timestamp and all. If you see number of inodes, inode is nothing but your path. In Linux machines, we'll call inodes. Number of blocks. See, this path and all will be in numbers only, guys. So we will not understand. That's the namespace IDs. Okay. If you see here, who is the user, who is the which group he is belong to, and whether he has a permission or not, what permission he has, right? What is the path? The path is slash example, and how many blocks. This like this, the information will be available in the FS image. So the same FS image as a text. See, this FS image and edit logs are not human readable. Those are not human readable. Those are the binary files. We have to convert them. Actually, I have converted. I'm showing here for your purpose. Your FS image and edit logs are not human readable. We have to convert it. So I have converted them as an XML file and also as a text file. We will see how to convert them. You can also convert. So there is a command to convert it. Okay. Now to solve the limitations of the name node, we introduced a machine called a secondary name node. Okay, let me explain you first, then I'll show you the slide. So what is the secondary name node, how it will solve the problem. Now let me clear this. So before that, let me take a simple example. So it will make you very much clear to understand what is a secondary name node. So we are the students, right? So let me take Srinivas. I'm taking out your name. Okay, Srinivas is my student. Okay, I'm getting some disturbance. I'm just keeping no, mute everyone. Okay, so Srinivas is my student. What the Srinivas is doing every day? He will attend the class. Okay, he will take the running notes. He will take the running notes. Okay, after taking the running notes, what he will do once he go back to the home, he will make the regular notes. He will prepare the regular notes. Okay, by referring this running notes. Okay, so what he is doing every day after the class. 1 second, guys, only 1 second. Actually, some announcement is going on outside, so I don't want to get disturbed. Okay, so is my voice is clear, or you guys are getting any disturbance?
It's clear.
It's clear, no issue.
Okay, so Srinivas, what he is doing every day, he will keeping the notes in the regular notes, and once he go back home, and he's preparing the running from the actual notes, from the running notes to proper notes, and every time he is doing that. Every time he is doing that. Then what he thought, he didn't do for 10 days. Let's say he just continued the class 10 days, and the 11th day, he thought to prepare a notes. So he has to do so much of transactions, like he has to do the notes from the last 10 days, right? Which will take so much of time, right? So what he thought, instead of that, I will hire an assistant. So your Srinivas thought that, okay, I'll hire an assistant. Let's say the assistant name is X. Okay, what assistant will do? Assistant responsibility is every day I'll give you the, so assistant has to come to Srinivas, and he has to take the regular notes, I mean class running notes, and he has to prepare the notes and keep it to him every day. It can be every day, it can be every 1 hour. Let's assume that. What is the assistant's job? The assistant job is every 1 hour or every day come to the Srinivas, take the edits, I mean the running notes, take the running notes and prepare a proper notes and prepare a proper notes. That's the assistant X job. Okay, now Srinivas, what the Srinivas is doing, now Srinivas can continue the classes without any interruption, no? So Srinivas can continue the class without any interruption because there is an assistant who can prepare the regular proper notes from the running notes, right? Let's assume that Srinivas has been thought that, I mean he re-entered the class. He attended, he missed 1 or 2 classes, he re-attended. When Srinivas thought himself he wants to prepare a notes, I mean he restarted, restarting here something called name node restarted. So the Srinivas will go to the assistant and he will take the notes and he will merge with the current running notes. Uh, is my example is going, guys? Are you guys
Yes,
able to follow?
yes, yes. Yeah,
So,
yeah.
so every time Srinivas is going, Srinivas thought that he want to merge the notes, or merge means prepare notes himself, he has to go to X and take the FS image, because the FS image means that regular notes is there with him, and Srinivas go has and talk to him, get that, and he has to merge himself. The same way here, if the secondary name node has been introduced to overcome the limitation of the name node. What is that? So we will keep another machine like an assistant. We have kept a machine called here. It's like an assistant machine, which is called secondary name node. Ideally, I have to draw here, but the space is not there. I'm drawing here, which is the secondary name node. What his job is, every 1 hour, go and talk to the name node, get the edits and fs image. Edit file, I mean running nodes and regular nodes, and he will merge it here. He'll merge it. He'll keep the final fs image, updated fs image, I mean regular nodes. What the secondary name node job is, every time, every 1 hour, go to the name node, every 1 hour go to the name node, every 1 hour go to the name node, get the edit file and fs image and merge these two and keep one updated fs image. So it will keep with him only, he will not give, he will keep with him only. The assistant, what he will do, he will keep the running nodes and regular nodes with him only. So what Srinivas will do, every day he will write in some chit, some paper, and the paper will give to the assistant. The assistant will take the paper and write it, and he'll keep the updated notes. So now your secondary name node, every 1 hour is going here, taking the edits and fs image and merging, taking edits. The next again it will take one more edit, and already he has fs image here. So he will merge this fs image with this guy and will create updated fs image. Like every day Srinivas is writing in a paper, that paper is giving to person X who will merge the nodes. Every day he is doing the same. And one day, all of a sudden, the name node restarted. What is the name node? So let's take an example. Here 8 o'clock the merges happen. 8 o'clock the merges happen. 8 o'clock the merges happen. 8 o'clock the merges happen, and the next merge is 9 o'clock, and next merge is 10 o'clock, next merge is 11 o'clock. So hourly basis, right? Your secondary name node will go and talk to a name node every 1 hour, right? That's the configuration. You can change it. Okay, default configuration. There is one more configuration. Not only 1 hour, whenever the 1 million transactions, like writing the data and modifying the data, editing, deleting the data. If you do 1 million transactions, these are the transactions. If you reach 1 million transactions, a name node will come and talk to secondary name node will come and talk to name node. So the merges happen 8 o'clock successfully, and the merges happen 9 o'clock successfully. Then at 9:30 name node restarted. So now your name node has to merge the copies. No, what is the first, whenever a name node restarts, what is the first task you will do? It will take the edits, reads the edits and merge with the fs image, right? That's the first task. So now your name node has the latest fs image. I mean, where it is there? It is there in the secondary name node. So when you configure the secondary name node, your secondary name node has till 9 o'clock. Whatever the fs image is here, till 9 o'clock it is up to date. It is still up to date 9 o'clock, because the merges happen, no? Are you guys able to follow?
Yeah.
Okay, so your secondary name node has the latest fs image, which is till 9 o'clock. Which is till 9 o'clock. So 9:30 the machine is restarted. Now your name node job is, it has to merge this edit from 9 o'clock to 9:30. Correct? It has to merge from 9 o'clock to half an hour edits. It has to merge. Your name node now to start merging, which is from the 9 o'clock to 9:30 changes. Only how many changes? Half an hour changes. How many changes it has to merge? So your name node can start now a little bit faster comparatively before.
Yeah.
So here the problem is, your name node, when it restart, your name node has to go and talk to a secondary name node. Hey, Mr. X, you have up-to-date nodes, no? Give me that, because I am going to write myself. Because your assistant will do hourly basis. If you come between in a before in between, so assistant will not do. Your assistant will not work. You have to take care of your work yourself. If it is at 9, if it's at 10 o'clock, your assistant could have do that work. But you came by 9:30 only. So who asked you to come by 9:30? So you came by 9:30, you do your work yourself. My job is will start by 10 o'clock only. So till 10 o'clock, I won't do any work of yours. Right? So what name node will do? Your name node will request the secondary name node. Give me the 9:30, I mean 9 o'clock FS image. Till 9 o'clock you have FS image, no? Give me that FS image. Then I have a edit log from 9 to 9:30 edit log.
Okay.
9 to 9:30 edit log. I have a 9 to 9:30 edit log, and you give me 9 o'clock FS image, which is the 9 o'clock FS image. I'll merge these two. I will merge these two. Who will merge this? Name node. So now we are reducing the restart time by introducing the secondary name node.
Yeah.
Everyone. So this is an important point, guys. Here only you will get so many interview questions. Venkat, Sunil.
Yes, sir.
Sunil.
Fine. Ravi.
Okay.
I'm okay.
Yeah. So we have reduced, instead of it's doing a merging from the very starting day or starting hour, we have merging only last half an hour, right? So I have improved the restart time. I have improved the restart time. Not only that, let's assume that your machine is gone. You're corrupted at 9:30. Your machine is corrupted. Your name node is corrupted at 9:30. If the corrupted means completely burnout. You are not able to take a recovery. You are not take out a recovery. It's completely burnout. See, there are so many tools. Even though your machine is burnout, you can if your sectors and tracks are good, we can take the backup. So I'm taking a very worst scenario. The name node is burnout. Your tracks and sectors of the hard disk is completely corrupted. You cannot take the backup. In that case, how much data we will lose? How much data we will lose?
Half an hour.
Last
Half an hour
after,
only. Very good. You guys are following. So last half an hour only I can lose the data, right? So only last half an hour data I will lose. I no need to lose. I will not lose the whole data.
Yes.
So now I'm saving my time. I'm saving the data. So by introducing the secondary name node, I'm saving all these things, right? So I have overcome the limitations.
Yeah.
No, still there is a limitation here. What is the limitation you see at the secondary name node?
Both got crashed.
If the both are crashed, we can't do anything. So that limitation also, that's also, there is another limitation. I mean, that also has been solved, the problem. I'll come to that point.
Okay. Okay.
So what is the limitation here? Whenever your name node restarts, your name node, while it's merging, your name node has to give a request to a secondary name node to take FS image, correct? It has to take the FS image, no? See, this is a name node machine, and this is a secondary name node machine. So whenever he restarts, he has to make a request, hey, give me that file, and your secondary name node will respond with it, right? Which may also take some time, no?
Yeah. Yes.
Okay. So to avoid that limitation, Hadoop come up with another machine called checkpoint node. Guys, please try to remember these terminologies: secondary name node, checkpoint node.
Okay.
The next one is checkpoint node. I'm not taking whole cluster here. I'm taking only two boxes. One is the name node box. Another one is the secondary name node box.
Okay.
This is the box for name node, and this is the box for secondary name node or checkpoint node. What, Ravi, you said there is a limitation secondary name node, but you are telling the checkpoint and the
Secondary name node both are same.
both are same. Yeah. So your checkpoint node also will do the same job what your secondary name node was doing. Okay, the only difference is it will take the edit log and fs image, it will merge it here. After merging, the latest up-to-date information will return back to the name node. Return back to the name node. Your secondary name node was not written back. So what scene was that thought? So what this guy, every time I know I go I need to go to this person X and I need to take the latest nodes. I don't like this guy. So replace this guy with a new guy. Who will return me the nodes? So now the Srinivas hired a person called Y. The person called Y. So what Y will do? The same job. He has to take the slips, merge them, and give back the nodes to Srinivas every day. So next time when Srinivas wants to do himself, you no need to give a request. He has up-to-date information with him. Right? Your checkpoint, what it will do, it will take the edits and FS image. It will take the edits and FS image. It will merge it. The up-to-date one, it will return back to the name node. And when your name node restarts, the same scenario, 8 o'clock, 9 o'clock, 10 o'clock. If it fails at 9, restarts at 9:30, this off node transactions has to be merged. So it no need to made a new request to the secondary name node because your name node has the 9 o'clock FS image himself, right?
Yes.
He can merge it. He no need to give a request to the secondary name node. He no need to give a request to the secondary name node. Clear, guys?
Yes.
So always the name node maintains the up-to-date image. Even your checkpoint also will keep the image. One copy will be there with him, and he will give the same copy to the name node. He will give the same copy to the name node. Now, still now I have improved my restarting time. So I have avoided the one request and response, right? Still, I have restarted. The restart time is improved. Clear, guys?
Yeah.
Yes.
About the checkpoint. So checkpoint is nothing but a secondary name node only. But the secondary name, the earlier version of the secondary name node, it was not having upload feature. So later they have named it as a checkpoint node where it come up with the upload feature, uploading the FS image back to name node. That's the only difference. If anyone asks you that what is the secondary name node and checkpoint node, there is no much difference. Your secondary name node is nothing, checkpoint node is nothing but a secondary name node. Your checkpoint node come up with a feature called upload back the latest image to name node. That's the only difference.
Okay.
Okay, let's go back to the slide. So you have a name node, you have a secondary name node. It will have the metadata. So what he'll do, he'll think that it has been an hour. Give me your metadata. Every 1 hour, it's a transaction. There is a configurations, guys. The configurations can be modified. I'll show you the configurations as well. Secondary name node help to overcome the above issues by taking over responsibility of merging edits with the FS image from the name node. So he has hired the assistant who is the secondary name node. The secondary name node job is not to be a secondary to a name node. Guys, don't think that secondary name, as soon as we say secondary name node, it means if the name node goes down, the secondary name node will take over the roles. No, he just is kind of a backup node. It's not even a backup node. He's just doing a merging task. He's just an assistant. He cannot take over your roles. See, the Srinivas as an assistant, can his assistant can no replace the Srinivas? No, he cannot. Right? Uh,
Why
sorry?
why is there any configuration difference or what?
Not the configuration difference. See, Srinivas regularly attended in classes. Okay, you didn't come for 10 days, and your assistant can come and replace your class.
No.
He cannot, right, Srinivas?
Yeah, yeah.
Because he may not be.
No, if I couldn't able to come
Sorry.
if I couldn't able to come permanently means in place of my place you have to take somebody else or secondary guy assistant can move to that position. What I'm saying, not 10 days. Permanently I will not come back.
Okay, so now the Srinivas is not coming permanently for the classes. Then he wants to send his assistant. That's what you're trying to say, right? See,
Yes,
here I cannot accept your assistant to my classes, right? How can I accept him?
okay.
Suppose if I am willing,
Yeah.
I can make him to replace you. The same
Yeah.
way,
Yeah. Yeah.
if your administrator is willing, your administrator, see, when the name node fails, goes down, he has to buy a new machine. He has to bring into the cluster.
Okay.
So he has to go for the new request and all. It will take so much of time. What he can do?
Yes, sir.
Okay, secondary name node machine is already available. Make temporarily
Yeah.
that he can do by your your administrator. It means that I can do.
Yes. Yes. Okay.
So instead of buying, by the time the new machine comes, so I can make use of the secondary name node because I don't want to keep my cluster down for a long time,
Okay.
right? So that your administrator can do that. Hadoop administration can do that. He can take a call. Okay, anyway, if I go and give a purchase request, procurement take will approval, and the procurement take they may get some time to get me the machine. Instead of that, there is a free machine which is available. Let me make it. That your administration can
Okay.
do that. Okay.
Okay. Fine.
So what does
Okay.
my meaning is secondary name node? Some people, when you say secondary name node, as soon as this goes down, this guy will come and take the roles. That cannot be the possible. That's not the case. Suppose he,
Only if the admin can able to do that,
yes,
he can replace,
yes,
but it's not default.
himself he cannot. Himself he
Yeah.
cannot.
Okay. Okay.
Okay. So don't think that if a name node goes by 9 o'clock, by 9:1 secondary name node can take the roles. No, he cannot take himself. Someone can ask. I mean, do this configuration changes. Not the configuration changes. Ideally, someone has to make him to name node. Okay, clear?
Okay. Yeah.
Sunil, Venkat.
Yes, Ravi.
Okay.
Yeah,
So
fine, Ravi.
yeah. So look at here how it looks. How it looks. The secondary name node. The secondary name node and checkpoint node both are same here. So what it will do? You have a name node. You have a secondary name node. The edits and fs image will be there in the name node. Every 1 hour this guy will take into secondary name node. It will copy. Okay, and he will merge it and will keep the updated one. So after updated one, he will give back to a name node. You give back to
Yeah.
the name node. So your name node knows it. I already given the edits and fs image to the secondary name node. And if any new transaction comes, he will not write into old edits. He will create a new edit. Understand?
Yeah.
And after some time, this edit and this fs image also will go to the secondary name node. That time again, it will create a new edit. So whenever it's every 1 hour, whenever your name node secondary name node requested for the edits and all, that time it will send the old edits and the fs image to a name node, and it will create the new edit log. Every time it will create a new edit log. Are you guys clear?
Yeah.
Any
Yeah.
doubts?
No, sir. So
Is this new edit is only, I mean, the new edits.new file will be used only when in case of failure, or it is for the next transactions?
No,
I
it is
mean,
for the next
for
transaction. Let's
example,
say, yeah, go ahead.
8 o'clock, the file is, secondary node has taken the file and it is merged.
Yep.
And 8:30 there is a failure happened. So when the name node restart, it uses the edits new to
Merge it. Correct.
create the new file, right?
Correct.
Okay. If there is no failure, that by 9 o'clock, the secondary name node takes the file of edits or edits new.
Edit new. Edits is a old file, no?
Okay.
So latest transactions are there in the edit new only.
Okay.
See, as soon as the edits are sent to at 8 o'clock, it's sent to the secondary name node. Now 8 to 1, let's assume that there is a 1 minute gap. Okay, 8 to 1, there is a transaction came. That time it will create a new edit.
Okay.
After giving back, what are the new transaction will start? It will write into the new file only.
Okay.
Okay. Are you guys able to follow? Is this clear, guys?
Yeah.
yes, Ravi. Once that given to secondary node, that old lag it will be as it is, or once it will merge after some time. It will be like that only. Once it's delivered to secondary node, it will be old, and new log will going to
it
create.
will be old. It will be old.
Old. Okay. Means every 1 hour it will keep one edit file.
Exactly. New
log.
edit file will be created.
Okay. Okay.
Yeah, clear?
Yes. Fine.
Okay. So next. Okay. Sorry guys. Okay. So can you guys tell me, is there any limitation here? Is there any limitation here? Do you guys find any limitation here?
Not sure.
Okay. Still have a data loss, no? So let's say 9:30 my machine is gone down completely. So I may lose the 30 minutes of data, right? So I don't want to lose that as well. I don't want to lose that as well. So that's the idea, right? So it is not like you should not lose any data in the production environment, right?
Yes. Yes.
For that, there is a new machine, one more machine has been introduced. See, these are all replacements, guys. So I'm showing all the replacements. The very old version is secondary name node, then checkpoint node. Even they found some limitation in the checkpoint node. Then they come up with it's called backup node. Here no request, no, see here every periodically I have to go and talk to a name node. Every 1 hour, every half an hour I have to go and talk to a name node. Suppose if any case, in case of any failure, there are data loss. But in case of backup node, there is one more term called backup node. Backup node. So in this case, your name node memory, RAM, and your backup node RAM is keep in syncing. So what are the transactions you do here? Those transactions will be available here.
Okay.
What are the transactions you do here? Those transactions will be available. The merging and all will take care of here. The merging and creating latest FSMS and all will take care here. Understand? So there is no time delay here. There is no possibility of data loss.
Yeah.
Right? All the transaction information is here. If this mission goes down, I have a mission here. So all the latest information is there here. I can go and bring it. Correct?
Yeah.
So that's the
But
backup.
FS image, the backup node will be creating the FS image very frequently.
Yes.
Okay.
See here.
Always. Okay.
Yep, always.
Always merging. Okay.
So the backup node provides the same functionality as the checkpoint node and secondary name node, but it's synchronized with the name node. It doesn't need to fetch the changes periodically because it receives the stream of file system edits from the name node. And it holds the current state in memory and just need to save this into image file to create a new checkpoint. It just save into image file always.
Okay.
So anyway, it will come to the memory, it will just save into image file.
Okay.
Clear?
Yes.
Yeah.
So what are the things we have seen? We have seen the name node, we have seen the secondary name node, we have seen the checkpoint node, now we have seen the backup node, right? So please keep a difference between all these four, don't confuse.
Okay.
Okay, let's go back how the backup node works. This is how it will work. Is to keep syncing with this. And yeah, before getting into this, I want to tell you a few more things. Let me go back here. Do you see any limitation here in the backup node?
Backup node at any moment it got crashes. Name node is working, no issue. But what will be the recovery for? What will be the
that information anyway? That information will be available in the name node also, no?
Name node. Once it's recovered, we'll keep it over there.
Yeah.
That's what. Okay.
Yeah. So is there any other limitation?
Here the backup node, I mean, if the name node failures,
Yep.
automatically become
No,
primary.
it will not take. Very good point.
It will not.
Right? What is the limitation?
Okay.
Okay. If again the name node failure, we need to wait for the administrator.
Exactly. There is nothing high availability here. There is no high availability here. Highly available. So to overcome that limitation, they come up with one more called, there are two data nodes, sorry, two name nodes. Here the name node itself is 2, not the single name node. The name node itself is 2. What is the active name node? Another standby name node. It's not secondary, it's the standby name node. Okay.
Okay.
Let's say you have so many machines here. Please bear with my drawing skill, please.
No issue, no issue.
Papa. Both the name nodes will be connected all the data nodes. Both the name nodes will be connected all the data nodes. Okay, and these two data nodes will maintain another node. It's not node, it can be any other system. It can be network area, storage area network system, or it can be any quorum, any other node, any other machine. So who will do the merges? Storage area network, network area, storage area network, I think SAN, yeah, SAN.
Yeah.
Okay, so this guy is active and this guy is standby. It means there is only one node, name node, who is responsible for writes the data. See, when the edits and all will go, as I said before, if you remember, only creating the data, modifying the data, and deleting the data, right? Then only your edit log will get entry. You just reading the data, it will not get any entry, right? If you remember,
Yeah.
right?
Yeah.
So that's all your write operations will go here. All your write operations will take care by active name node. Your read operations will take care by secondary name node. I mean standby name node. Your standby name node. Understand?
Okay.
All
But
your write
edit logs
operations.
will be
Yeah.
in SAN storage,
Yes.
which
The
is
edit.
accessible by
Yes. Yes. The SAN storage. This
accessible.
edit log and this FS image will be shared by here.
Okay. So the name node will not have the edit log in its hard disk any point of time. It's always refers to SAN storage.
Correct.
Okay.
And this is storage area network where it can edit and FS image will be available for both the nodes.
Okay.
Okay. Suppose this machine goes down.
Okay. One question
Yeah.
here.
Yeah.
Every time the standby node has to take the edit image from the SAN storage, so the read will be get slow, right? Because any moment there is an update transaction happen from the main name node.
Correct. That
Name node.
information will be in the stand. Your name anyway. Your secondary name node is already synced with this guy, right? It's already in the shared location, right? It will be available with him. When you go on the
But it is in
developer,
the hard. It is. I mean, earlier approach it was there in the RAM to process. It is faster.
now what's it will be in the
Now,
RAM? Now what's it will be in the RAM? In the name node RAM
No,
it will be
I
there.
agree. Name node RAM it will be there, agreed. But it does only the write operations,
Hmm.
transactions.
Hmm.
When it comes to the read operation, I mean, I'm looking for a report which goes to the
Hmm.
secondary name node.
Correct.
So now the secondary name node has to read the edit files from SAN storage,
That's all.
because
That information already read right here. I already copied before. No, I already taken that information, right? If it's a very brand new information is written, just now you written and you're trying to read immediately.
maybe. I mean, for example, I am a vendor who provides the data. My client is looking for the data.
Hmm.
So the vendor's data comes in, and at the same time the request came for this thing.
Read.
I mean,
Read.
read also.
Yeah, that time we'll just go and
Yeah.
refer the information here. So I mean, it won't take much time, right? You just need to get the information. This is a small message. It's not actually taking the data, right? Information, metadata only it is taking.
No, no. You said the FS image will be merged in the SAN storage itself.
See,
It's not by the any of the
see,
name node or the standby name node.
see. Merge in the sense it will be okay. In the when it comes to the stand storage, it will be okay. So let me think how it will work in the administration point of view. Uh, it will be there. They were FS image, correct? All your read and write operations, write operations will go through this, and read operations will go through this, correct? And yeah, as soon as you write it, the updates will go here, right? In the SAN storage, correct? Yeah.
Yeah,
Uh,
that's fine. But my question is, I mean, when the read operation happens, I mean, the standby node has to always refers to the SAN storage to get the fresh edit file.
it has to get it.
If okay, that might slow down. That's what my question is.
You know how much it will not slow down, right? It's already it will be reading, right?
I
I
mean,
think it,
it will not be faster as is in the RAM, right?
but at least that's correct. See what it will do as soon as it get updated here. I think it will. I mean, I'm not sure about this point. I'll come back to you. And what I'm
Okay,
assuming, it will immediately read and keep in the RAM. I
okay,
think it will keep sync with your SAN storage.
okay.
And one more thing here, when it goes down of this machine, see
Hmm.
immediately he's taking care of the roles. He knows all the information.
Yeah, that is fine. Because he uses the FS image from the SAN. That's fine. I
Hmm.
mean, that's recovery is fine. But my question is for the read, there might be a delay in this approach. That's what my,
That
I
I'll
mean,
just check.
this is the
I
concern.
don't think it will be so much of delay, because as soon as you return
Yeah.
into SAN, your secondary name node, standby name node will pick that same information available
Okay.
in the standby name node. So I'll
Okay.
check it. Okay,
Yeah.
I'll
Yeah.
come back
Fine.
on this.
Fine.
Let me
No
keep it in the
problem.
parking lot. I'll come back to this.
No problem. No problem.
Okay, now it is avoiding your all the issues.
Okay. How that? I mean, only the standby node. If the name node goes down, how the write operation will be? It will be standby node will take care of the write
Yes,
operation as well.
yes, it will take care of the both.
Okay. Uh,
When it has a two machines, they will share the load. So when you have only one machine, because of something happened, one machine goes down, so the load will take care. But for the time being, right? Anyway, your client, your administrator will be keep an eye. Like he'll be getting the messages, emails, right? This machine is gone down. This machine is that, right? So
yeah.
a little time, yes, that machine will handle.
Okay, the request came in during that time. It will also redirect to the secondary node, or is there any
The request will go to
failure?
the failure node. Anyway, it will not be available. Your client knows it, right? So one more thing
Okay.
here. So when you're going to send the request from the client, right?
Mm-hmm.
So what are the configurations are there in these machines? The same configuration should be available in the client machine. Client machine also will have a Hadoop software. So what are the
Okay.
configurations you have done for the standby name? All the information will be available here. So as soon as you'll try, it finds that the secondary name node is active name node is failed. You'll directly go and talk to the secondary standby name node.
Okay. Okay. Even the client machine knows all the
Yes,
information,
yes,
even
yes,
information about the SANs. SAN.
yes,
Okay.
yes.
Secondary.
It knows it.
Means it's parallelly updating to both name node and SAM as well,
SAN.
right?
Yeah.
SAM machine as well, right?
Yes,
Okay,
yes.
okay.
Okay.
Yeah.
Okay. So do you find any limitation here? This is called HDFS high availability. If anyone asks you what is a high availability, this is how the high availability works. It's a highly
Okay.
available. Do you see any limitations here? Actually, the Suprit, you have raised the question, right? That's not a limitation. I think it is keep sync. Um,
Okay.
so I'll come to that point. I'll explain you this. So that's not the limitation. Is there anything else apart from that?
Oops, okay.
No limitations, right? We didn't find any limitations here.
Yeah.
It's highly available. So you have there is no data loss. The restart time is there. If one machine goes down, I have a immediate who will take care of the roles. So I have
Okay.
everything is available, right? So this is the final stage. I mean, highly available clusters. So they'll keep people will be using in the real time the highly available cluster. Okay. And there is one more
Yeah.
concept called federation.
Uh-huh.
There is one more it's not a limitation. It's not something. It's not no the federation limitation of the that it is a new concept. When you have a huge number of cluster, you have 1,000 nodes of cluster. If you have 1,000 nodes of cluster, what will happen? So the whole burden will go to a single machine, single name node.
Yeah. Yes.
To overcome that burden, they're sharing the load. Actually, they're sharing the load now. How they will share? They will have a two name nodes. They will
Uh-huh.
have a two name nodes. Name node 1, name node 2. So you may have a backup node of this. Let me finish my drawing here. NN1, NN2. You can have a highly available for this. You can have a secondary name node for this. You can have anything. That's up to you. Okay. What it will do? Let's have you have so many missions here. Small missions. I'm just taking small. So just okay. You- 1 second, guys. Sorry guys, actually my kid fall down, so I just went there.
Okay, no problem.
Yeah. So this federation, this is federation, okay, Hdfs federation. So federation. So here what will happen, all the machines will be connected to all the machines. Both the name nodes will be connected to all the name nodes and all the data nodes. Bapre, the drawing is going in the worst. Okay. So all the machines will be connected. All the machines are connected to all the machines. So now here there are so many machines, right? There are so many machines. If only one name node, so when I load the data, that's a burden to a single name node because it has to maintain the resource management, it has to identify the which resource is free, it has to launch a new job if any job is submitted, and it has to spread, it has to load balancing and all, it has to take care, right? So instead of that, what the HF Federation says that you keep two data nodes. Okay, this data node can have its own backup node. It can have its own high availability. That's its own. Okay, this can name node 2 can have its own all other things. Thus this name node 1 also can have its own backup node and all. Okay, what is happening here? When you start loading the data, what the name node 1 says, I will handle if anyone store the data under slash user. This is my directory. So let's assume that, let's take an example here. Okay, let me take an example. We'll be having a path, we'll be having a root directory, right? So I have a root directory like this. Under the root directory I have a user and I have a share. I have user and share. So under this I can have any number, and under this I can have any number, right? If anyone stores the data, stores the data by using the command put command slash user, they give a destination as slash user slash something. Okay, if they give any destination directory as this, I mean this is the what we have to consider. Okay, slash user. If anyone give the destination as the slash user, and I will go to name node 1. If anyone gives the destination as the slash share slash something, I will go to name node 2. Understand here, if anyone loads the data under slash user and it's a subdirectories, that will handle by name node 1. If anyone stores the data under slash share under subdirectories, it will handle by name node 2. Are you guys able to follow?
That means
Yeah.
client himself
He knows it. He
dictating
knows it.
it.
Yes. Client himself, he
And
knows it.
he's correct. He is dictating it which name must be used.
Exactly.
I mean, it's not kind of a load balance. Based on the load, the file will be moved to name node 1 or name node 2. It's someone forcing it, right?
Yeah, it's actually what it will happen. It will maintain the cluster ID and block pool IDs. Okay, that's deciding by client. Ideally, it's deciding by client. But so when you look at the whole overall, it means instead of maintaining this much big cluster, so we are loading, we are separating the, we are introducing two managers in the team. Let's say you have a team of 60 members, so that's a very difficult to manage by a single manager. So what we will do, we will hire one more manager. We'll say tell him that, okay, I'll handle these 30 members, you handle these 30 members. I'll handle only testing team. So you'll hire one testing manager and you'll keep that. Okay, that's a whole are doing the same project. Okay, all guys are belong to a single project. The 60 members are there for the single account. and two managers. So one manager says that, okay, I'll handle all the testing team. One manager says that I'll handle all your development team, and another manager may say that I will handle the data team. So what we are doing, instead of managing this 90 or 60 members of team by single manager, testing work, development work, and backup work, background work, so we will hire the separate manager. So it's ideally we're reducing the burden on the single manager, right? It's ideally reducing the load on the single manager, right?
That I agreed, but the question, I mean, my question is, I mean, say for example, I am a client.
Hmm.
I don't want to know that who is the name node who is going to take it, right?
Correct.
I mean, I just give a request, and whoever is free, then they will accept my request and they process it. That's how it should work, right? I mean, as a distributed technology. I mean, I'm comparing with the load balance. You know the load balance, how it works, right?
Correct.
As an developer, I mean web developer, I work with that.
Okay.
I'm comparing with that technology here. The load balancer, when the request comes, it depending on the resource availability on both the multiple servers, it distributes.
Okay.
Is it the here you are saying it's client is forcing, saying that use this, you use this node, use this node. I mean,
Yeah.
that's
Here
my confusion.
here the client is, which client you are talking about? Are you talking about Hadoop client, or are you
The
talking about end client?
requester, whoever it is.
Okay. See, here we
No,
need to.
you are saying user and the share. I mean, I got confused there.
Okay, I'll tell you this. So I'll be having one more client here. Let me put in this guy in the central. This is a machine where I'll execute my commands, right?
Okay, yeah.
I'll call is a client. He's a Hdfs client. Hdfs means if you are submitting any Hdfs job, we'll call him as a Hdfs client. If you are sending any MapReduce like a processing job, we'll call it job client or MapReduce job client. Okay, so this client is also have the same software, same configuration, everything same. Okay, whatever the name node. See here, what we need to remember one thing, guys. So whatever the configurations are there in the name node, the same configurations will be available in the data nodes. The same configuration will be available in the client as well. They should. It has to be across all the machines. Should be the same configuration. The same information will be there. Okay. Now, so this is the client. So because my data will go to the cluster from the here only. That can be this mission, that can be this mission, based on the data, based on the path IQ. Okay, so if you are talking about this client identifies. If you're talking about this client identifies based on the path you are giving. That's called cluster ID or block pool ID.
Okay.
See, for me it's a single path, right? You know it. For me it is a single path.
Yeah.
For end user, for the client, it's a single path. The HDF is a single path, right? If you are giving a single path / user, that data will handle by this guy. So load balancing, I think it may not the right word for this. It may not right word for this the approach, but this is how it will work. The federation works like this. Okay, if you're putting the data as a destination in the / user folder, it will handle by the name node 1. So if you're put the destination as a share like this. Okay, let me show you the Hadoop command, how it will comes. It comes a Hadoop fs -put is the command, and you'll give the source from where I need to get the data, the source location of the data. Okay, / your source directory and destination directory. You here will give the HDFS directory destination. If you say under show under user / Supreet, if you say this, okay, it will handle by the name node 1. The request will go to the name node 1. So instead of that, if you say / user, if you say /share /Supreet, Supreet can be there in both the folders. No, it can be possible because the parent directories are two different. So when you give this as the destination, the data is going to HDFS only. The data is not going out of the HDFS. The data is going to HDFS only. But we have a two different kind of people who will manage the person. I mean, who's manage the cluster. So when you say /share and Supreet, that will handle with the name node 2. That's how we'll configure it.
Okay.
I mean, do you understand the concept?
Yeah, I understood, but I mean,
Load
I was pretty
balancing, yes,
confused
correct.
with, yeah.
Load balancing, see, yeah, so as per the your web applications, like if you take any web servers also, based on the resource available, it will go and assign that task to that the no
Machine.
that machine. Correct,
Yeah.
but maybe the load balancing is not a suitable word for this. It's a federation. This is how the data will be handled.
Fine.
Yeah.
Yeah, yeah.
So this is the Hdfs Federation. So if anyone asks you what is the Hdfs Federation, how will you do set up the Hdfs Federation? This is how we'll do. And name node 1, he can have its own backup node, he can have its own high availability. Name node 2 can also have its own high availability or his own backup node. Okay.
Okay.
Yeah. So let's look at them the nodes wise. So let me show you here. I think I have given the nodes as available here. The specific documents are there for each and every topic. We have the nodes available for there. Yeah, for the secondary name node and safe mode, you have the proper nodes here. So what is the secondary name node, how it will work, what are the configurations? This is the configuration for the checkpoint, and this is the configuration the number of transactions. So here the configurations, how the configurations will go. What is the safe mode, what is the safe mode, how the safe mode you can get the status, and how can you put into the safe mode. These commands anyway will execute, not to worry about that. And for the federation, let me show you federation. It's speculative execution, data nodes. I'll show you something. Let me check it here. Is there yeah, I have those nodes with you. I'll share the how to configure federation, how to configure high availability, fs image and edit log, demons. Okay, I think here it is not there, and here it will be there. Okay. Your fs image secondary name node and high availability. This is how the high availability looks. Anyway, I'll share this document to you guys. Your network area, storage or storage area network, whatever it is, shared location. Actually, it's a shared location. Not only that, you can have a zookeeper or you can have a quorum nodes. There are multiple ways you can configure no, high availability. So if anyone wants to become administrator, this document helps a lot for them. Okay, so this is, I'll share this document. When it comes to federation also will come like this, that you'll be having the two different name nodes, and based on the namespace, or based on the block pool ID or cluster ID, that will be decided which data node has to access. See here, he will configure two different data nodes, and here namespace 1 handled by this machine, and namespace 2 handled by this machine. Here name node 1 is nothing but you have to give your IP address. Okay, so this is the federation. These are the configuration parameters. Okay, so I'll share these documents so you guys can go through them. So next, what we need to start, the commands. Okay, so already 10 o'clock. I know you guys are sitting from 6:30 to almost 2.5 hour now, or 3.5 hour. So we can leave for the day today,
Yes.
and we will continue